Welcome to Unit 9. This is 9.1 area. We'll start with the formulas for area of the known shapes. So a rectangle is length times width, or base times height. A square is the same, except the base and the height are the same, so we're just going to say it's a side length squared. Parallelogram is base times height as well. Triangle, we add something in extra, which is 1/2 times base times height. And circle is pi r squared. So these were the known shapes. Now we can deal with the shapes that we don't know the formulas for. So a trapezoid. A trapezoid is 1/2 times the sum of the bases times the height. So 1/2 base 1 plus base 2 times the height. So we can use this formula for finding the area of the trapezoid. Base 1 is 3.1, base 2 is 8.7. It doesn't matter which one's which, but the height is 3. That 5.6 is the slant, and that only helps us with perimeter. So we substitute our values in, and then we just multiply, and we get 18 square yards. If we want to go backwards, we're going to fill in all of the information we know, then we're going to solve for x. So here we have the height, it's 10. One of the bases is 3.3, the other one's x. Fill that in, and then we can do half of 10, which is just 5. And we can divide 71 by 5 to get the parentheses by itself. 3.3 plus x equals 14.2. Now we can subtract 3.3 to solve. Base 2 is 10.9. Our next formula we need to know is the rhombus formula. It's 1/2 the diagonals multiplied by each other. So 1/2 diagonal 1 times diagonal 2. Unless it specifically tells us, we're going to assume that these lengths right here that we're given, these are the diagonals. Because it doesn't tell us if it's the half or the whole, and looking at our formula, D1 was the whole length, and it was just at a portion of it. So here the formula is 1/2 D1 times D2. Our diagonals are 10 and 14. We multiply those, take half, and we get 70. On this rhombus, it specifically tells us. So the 20 is the whole diagonal from Q to S. And then it tells us from Q to the center is 10. We also know that QR is 16. We can use Pythagorean theorem. One of the side lengths is 10. The hypotenuse is 16. To find the other diagonal, we're going to do 16 squared minus 10 squared to get 156. So B equals 12.49. So the whole diagonal is twice that, which is 25. So one of our diagonals is 20, the other one's 25, and we get 250 for our area. To go backwards, we're given the area is 25.2. We're going to set it equal to 1/2 times D1 times D2. D1 is 6, D2 is x. Half of 6 is 3, so we get 3x. Divided by 3, we get 8.4 for diagonal 2. The last shape we want to deal with is the kite, and it's actually the same formula as a rhombus. It's 1/2 diagonal 1 times diagonal 2. With kite, our diagonals aren't, like it doesn't cut the, it doesn't bisect the segment. So here we have to actually figure out what the diagonals are. On the left kite, one of the diagonals is 6, and the other diagonal is 13. 6 times 13 divided by 2 is 39 square meters. The right one, we have 3, we have 8, so that length is 11. The other length, well, we have an isosceles triangle in the top right, knowing that both sides are the same. It's 45, 45, 90. So the lengths of each part of the diagonal are also 3. So that diagonal is 6. So 11 times 6 divided by 2 is 33 square centimeters. Now to go backwards on a diagonal, same thing. We set up the formula. 8.8 is the area. One of the diagonals is 8. The other diagonal is x. Half of 8 is 4. Divided by 4 is 2.2 meters. All right, so that is it for the area of 2D shapes. Good luck on the practice application. Let's check.